Hello, my name is Dino Veland, and today I'll be giving you a demo of the profiling features in Python tools for Visual Studio. I'm going to get started by first opening Visual Studio. I've already created a project that includes the Pystone benchmark, so I'm just going to go ahead and open this. This is a very simple benchmark, but it's included with every version of Python, so it'll let you follow along at home and see how this all works. The first thing I'm going to do is go into the project properties, and I'm going to give this script some arguments. This is just the number of iterations of Pystone that I actually want to run. Usually this is 50,000. I'm going to actually go ahead and crank this down for a profiling run just so that it finishes in a reasonable amount of time. I'll go ahead and save those properties for my project, and at this point I'm ready to go ahead and launch the project. To launch the project under Profiling, I can go to the Analyze menu and choose Launch Python Profiling. This will bring up this small wizard that lets me select either a standalone script to be profiled or select one of my existing projects that's loaded in Visual Studio. I'm just going to go ahead and select my existing Pystone project here. With that, I can just press OK and we'll go ahead and launch the program and start profiling it. You can see that my Python starts running, finishes, and here we go, and we launch into the report view. So first we'll prepare the report, which will take a little bit of time depending on how much data was collected. We haven't collected a tremendous amount of data, so this will actually finish pretty quickly. And there we can see the initial report that Visual Studio has generated. First, let me just resize some of these windows so that we can see that full report and really drill in and see everything that there's here to offer. In this initial summary, you can see the most expensive call path, which might be the thing that I want to drill down into initially and look at if I'm going to try to figure out where all of my performance is going. This includes both the inclusive time, this is the total amount of time spent in that function and any functions that we've called, as well as the exclusive of time, which is just the amount of time that we're spending within that actual function. We also have some information down below about the functions which are doing the most individual work. If I wanted to optimize one of these in order to improve the performance of my program, I'd probably start looking at proc0 first and proc1 next and see which ones I can get some additional performance from. From the summary view, I can start drilling into the individual functions. So let's go ahead and look at pystone.proc0. Here you can see that the caller of proc0, which is just our main script, and you can also see the functions that are being called by proc0. We start off with the function body of proc0 itself, and then the individual functions that are being called are sorted in the order of their CPU time. I also get a nice view of the source code here. This screen is a little bit small for the purposes of the demo, but you can imagine that on a normal developer machine you get a nice overview of not only the CPU that's being spent, but you can also look at the code at the same time. That gives you a feel for some of the more graphical display within the profiler, but I frequently find some of these other views to be extremely useful. So you can see that we have a summary, a call tree, a modules view, a caller callee view, a functions view, a marks view, a processes view, and a function details view. And so far we've just seen the summary and function details views. Next we'll look at the caller callee view. This is actually one of my favorite views because it lets you quickly jump around within the call stack and see where your CPU time is going. So you can see that we're at the current function, the Pystone module, and we can see all of the things that these have called. I can go ahead and sort by inclusive time, and we can see that Pystone main is using most of our time. I can quickly drill into that, and I can see that that calls the Pystones function. And again, drill into that and see that that calls proc0, which we were looking at before. One more drill down, and we can start to see all of the interesting things that proc0 calls. Here I can sort by either inclusive time, which includes the time spent in the function and anything it calls, or exclusive time. I find inclusive time is very useful to figure out what is actually using all of the CPU time at a high level, and usually once I've figured that out, I start going and looking at my exclusive time to find the individual functions which are doing all of the computation. So let's start drilling down into what this is doing. Let's look at proc1 first. Okay. Proc1 is calling several methods. Proc6 is the most interesting one, it looks like, so let's look at that. And we can see that that's calling func3. So let's go ahead and see what func3 is spending all of its time doing. I'm just going to right click here and go to view source. Well, it doesn't look like func3 is actually doing much. We just have a parameter that's coming in, and we're doing a assignment into this local. We're comparing the local against ident3 here. Let's go ahead and see what that is. Well, that's just going to be the constant 3. And we can see that we're returning true and we're returning false. And if we go and take a look at those, we can see that true is 1 and false is 0. So those are just constants themselves. So this code is actually a little bit difficult to optimize because it's not doing much. So instead, I'm going to actually slow the code down for the purposes of this demo. So what I'll do here is just go ahead and interject a really short sleep each time we encounter this hot function. From here, I'm just going to rerun the analysis and see what the new results are. So I go to Analyze, choose my existing project, hit OK again. That launches the new run. I go ahead and wait for that to complete. Doesn't take very long, despite the extra sleep. And we can see here that we once again get our call tree. So I can drill in. Let's start at proc 0. Okay, let's go ahead and switch to our callee view that I liked so much before. Short that by inclusive time, and we can start drilling down to proc 1, into proc 6 again, and here we can see func3. And if we compare that to what we had before, func3 sure is taking a whole lot more time. So in this case, of course, I knew the offending function, so it was pretty easy to drill into it. But let's say I was comparing two different builds where a performance regression happened, and I was trying to figure out specifically what happened. For that, we can use the compare reports option that's over here on the summary page. So I just select compare reports, and I give it the two file names. So let's go ahead and give it our second file name of the file that we've been doing this analysis against, and I'll click OK. And that'll just go ahead and pop open the comparison report page, which gives me a nice view. And I can see that time.sleep went way up, and the other numbers went way down. And that's just because of the relativity between the total sum of the entire time being spent within the program. We spent more time running the second program, and it spent a lot of time in time.sleep, so a lower proportion of the time was spent in the other functions. I can also get other views on this, so instead of looking at the exclusive time %, I can go and look at just the raw exclusive time, and that you'll see time.sleep jumps way up, and our deltas here are now a little bit smaller and more reasonable. I can also go and look at inclusive time to kind of understand functions and where all the time is being spent, and you can now start to see that all of my callers of the function that ultimately called time.sleep also have their amount of times jump way up. So this is a really useful tool for kind of drilling in and looking at two different builds, comparing them, and figuring out where the performance delta came from. So that's a basic overview of the profiling feature in Python tools for Visual Studio. One other thing that you should be aware of, this feature is only available in Visual Studio Ultimate. That's because PTVS is building upon the same infrastructure that C#, C++, JavaScript, and other languages use for their profiling. So you'll see that you get the same user experience here as if you're using one of those languages, including all of the same features that you know and expect. I hope this video taught you something new, and have fun profiling!